Hello, my name's Eli Davis. This is part 3 of a mini-series on how you can use my extension Record and Play inside of your Unity application. If you want to understand how you can build recordings, I would recommend looking back at part 1 and 2 of the series, where you build recordings either through the editor or through your program. This will look specifically at how you can build this playback behavior so you can take a recording and do your custom stuff that you want to. That is domain specific. So for example, on Overwatch, you might have these kill cams going on, which are constantly building these recordings, and then in the end, when you want to show everyone the kill of the game or whatever, you would then have your playback software run on that recording and then do everything properly to reenact what happened. So we're going to be using stuff like metadata and custom events that we logged previously to properly build back a recording. So this is a empty Unity project. We do have artifacts from the previous videos that we've been building. There is an extra prefab in the assets folder, which is this collision effect. It is just a particle emitter that just builds a burst of 100 particles on start and then fades out. Very simple. And then we do have this playback example, which is an empty script with nothing to it. And that's where we'll be starting today. Cool. So if you want to do anything playback, first you got to import the playback namespace. Pretty simple. And you will be using playback behavior. So we'll make that a variable to this class. And also we need to be using the namespace just record and play, because that contains our basic classes like the recording itself. And so the recording itself, we're gonna let it, the user the game maker pass it in, just for sake of example. So we'll make it a serializable field, and then we're gonna build our playback behavior. So building playback is pretty simple. You just say playback behavior.build. Playback behavior is a mono behavior, which means you can't create constructors. So I've added this static method build to act as a helper to create your class and do everything you need for it. Build takes just the recording, or it can get into other stuff that we can go into later, but just to get the point across right now, we have this playback behavior, and then you need to somehow control it. So sometimes you can control it through code. I'm going to control it through the GUI just for sake of example, but you do what you need to do to make it work. So we can go through the motions. First off, I guess, if playback behavior is null, we want to return. Now, the real stuff. If playback behavior is currently stopped, then we want to allow the player to play it. Or, yeah, in this example, the player to play the recording. Playback, or we need to create some GUI. So we'll be using GUI layout to build that real quick. Button, and we'll say play. Cool. When the person clicks play, playback behavior dot play. Pretty simple. Else, if the current playback behavior is currently paused, then we want to either allow, currently playing. We want to allow the player to either pause or stop the recording. So pause or stop. And guess what you have to say to pause or stop recording? Pause or stop, or the playback. So what's the difference between pause and stop? So with pause, think in freeze tag when you tag your friend. they gotta like kind of stop and stay still or whatnot. That's kind of what pause is doing. So there's this playback going on, all these actors are moving, and then you have pause and they all freeze. As opposed to the stop method, which does like a Thanos snap and kills all the actors. And it resets the playback to time step 0. Also, when you're in pause mode, you can kind of piece through. You can change the time in which the playback is currently at, so you can change it from like 5 to 2 seconds or whatever. You can't do that in stop. It will throw an error. So that's kind of what pause and stop does. So the last thing to do is else if we are pause, then we want to either allow the player to play, and we'll still allow them to stop. And that should get our basic recording playback stuff done. And we'll let it compile. And it gives us an error because it doesn't understand that serialized field does stuff. So we'll drag playback behavior example over. It wants a recording, so we'll give it this recording, and we can just look at this recording real quick, what we're looking at. This recording was built last video, so it just drops these boxes around and whatnot. One should raise and the other should raise. So that's what we're dealing with. And so if we go, let's make sure everything's, directional light. Cool, we'll hit play. We should be presented with some GUI controls. Perfect, so if we hit play in our GUI controls, the recording should start. And I should be able to pause it. And you see that it's frozen in time and all that. I can replay or pause again. And I stop it, Thanos snap, it's all gone. Cool. So that's the basics of playback, but really what you're going to be dealing with is you want some actor representation, you want to represent the player or some enemies, and you want to do stuff with certain events happen. So this really isn't good enough for most people. So let's look at what we can do to extend this playback. The first thing we can do is specify some new actors. So given some information about the subject that was recorded, we can build a better representation for that subject. So this is an interface, and I'll be lazy and implement the interface in this class. Generally, I would implement the interface in a separate class. And please, oh my gosh, I am having a spaz attack. Cool. Implement this interface, and we'll pass in this interface. We'll ignore the custom event handler for now, and we'll have it loop. Cool, so let's look at what this actor build function does, which is a part of this interface. So it's passed 3 different parameters. The first parameter is a unique ID, so all subjects in a recording will have a unique ID. So like let's say you have 7 different boxes, all named box. To differentiate between them, you can look at their unique ID, their actor ID. So you can use that if needed. Then you have the actor name, so you can use that as needed if you want to instantiate the correct representation for the subject. And then you also have metadata. And so previously we looked at setting global metadata. You can set metadata per actor and all that. So if you want to do something special with instantiating a cool actor representation based on what happened in the recording. So let's say this box fell a lot, then you could make the box, you could take into account how many times it fell and make the box like redder. So you can build this kind of like analytics thing going on. So you can, at the start of the scene, you might even have like 100 boxes, but at the start of the scene, you could color all the boxes different colors, and you could look at, oh, this box fell a lot, let's watch it specifically through this recording. Really weird abstract stuff. It will probably make sense once you start to implement it, and it's going to be very specific to your domain, obviously. So with that, we really don't care about any of this information, but I will show you what it looks like when you return a new actor for the playback. So you can either supply just the representation or custom event handler. We'll get into custom event handler in a second. So for just a custom representation, we will just use a sphere for sake of example, so you see the difference. Game object that create primitive. Cool. And we need to, yeah, we've already passed the playback behavior, this class for the actor builder, and that should do it. Oh, cool. I messed up already. There you go. Please do not yell at me. I am very fragile. Here we go. Compiling. Everything's cool. And hopefully everything will be a sphere once we play. Boop. Awesome. So we have spheres being used now instead of cubes. So obviously you would make this specific to what you're trying to do. And I think that's good enough for that. So let's talk about the second part. What are these custom event handlers? Well, if we looked at if you watch the second video in this series, you would see us logging these custom events. In that video, we logged global custom events, so custom events that happen to the recording itself, not to a specific subject. But they work just the same way. So we'll also implement that interface and look at what you need to do to make it work. Please fix me. Cool, and we'll pass in this class to the playback behavior. So as the playback of a certain recording is happening, when you come across that custom event that got logged, it will then call this onCustomEvent function. So it's going to pass you the subject that the event is specific to and the event itself. If the event is global, the subject will be null, so you will have to take that into account. We don't care about the subject because we were doing global custom event capture, but that won't always be the case, and I'm just being very lazy. So, but we do have some cool information in this custom event. If we look back at our game behavior last video, we actually logged the point in collision that happened. So this box collision. So we can look at this and we go, if the name is equal to box collision. I copy and paste because I'm bad at spelling and I'm not even consistent with my bad spelling, so I copy and paste. Then we will perform our event. And so we will first get the coordinates out of the event. So var coords equals custom event dot contents dot split, and you take a character, and then we build a position from these coordinates. Equals new vector 3, and you'll take a flow dot parse, cool, chord 0 2 3 2 1. There we go. So this should correspond to X, Y, and Z and this string that we build. So now that we have this vector 3, we can then we're going to use that particle emitter that I showed you at the beginning of this video. So we will create a game object, a collision, particle emitter. It's a horrible name. And then we'll also make that serialized fields for people to drag and drop. And we will instantiate this object at the correct position. And also we will destroy this after a certain amount of time, so we can clean up the scene. So we would say destroy, we'll pass it, and we'll say 0.45 or something. So this is a pretty arbitrary number. This number comes from the particle emitter, loops every half second, and so I'm killing it before it loops. So with that, we should have everything working, hopefully. Yeah, and we still see that it doesn't understand serialized fields. That's cool, and we'll give it the collision effect. And then hopefully everything will work. And if it doesn't, I will fix it. So we'll hit play. Boom, perfect, awesome. So it observed that this event happened at this certain point in time and where it happened, and then it plays this effect. So that's great, that's what we want. So I can pause it, boom, awesome. So that looks pretty good. So let's recap what's happening. We're building this playback behavior, and we're passing it both an actor builder and a custom event handler. This actor builder is always global. It's always going to be in charge of building every single actor. There's really no changing that. This custom event handler, though, you can make it global, or you can do it per subject. So what we've done is made this global. However, if we had custom events happening to a specific subject, then we could pass the subject or the actor we're building, we could pass it its own custom event handler. In that scenario, we know that this subject being passed in is always not null, and it's always going to be the same subject. So what you could do is create a class per subject. So you, like, for Overwatch, you might create like a Mercy class that is in charge of taking care of all her custom events and all that. And you might, for your game, just have an enemy, a specific enemy. So like Kingdom Hearts Heartless. So Heartless.attack or something, you would have that class take care of all the custom events for that thing. So this actor builder would be in charge of wiring up all these event handlers to the specific representations and all that. So this is a very just generic example. But I think it might get all the basic functionality across. I will talk a little bit about area scale. So I was very specific to make sure that all objects that exist, or all actors that exist, are captured within this parent. And so let's say you might want like a mini representation of what happened. So you might have a war game, and you might have had all this stuff happen in war, and now you want this cute little war table to replay everything and like post-op. You could build a recording, and then you could just shrink it down, and it will take into account that shrinkage, and you can move it around, and you can rotate it, and everything will work. And it looks kind of funny. But so you can just mess with that, and so, or you can do the vice versa and make it super large and do crazy stuff like that. So that feature does exist. We can also make this recording run forwards and backwards. You saw that in the editor. And yeah, I think that kind of wraps up this video. And I'll see you in the next video when we talk about exporting and importing these recordings. So see you there.